All right, we're going to use the Lagrange multipliers to locate the points on the surface y squared equals x times z plus 2 that are closest to the origin. So really the surface itself is the constraint. You could say y squared minus x times z minus 2 equals 0. This guy is your g. This is a constraint.
That makes sense.
And then you're going to minimize the distance, right? Or the square of the distance, really. Yeah, so your f of x, yeah, I guess we could use f of x, y, z. Well, since we're comparing it with the distance to the origin, the distance formula is just going to be x squared plus y squared plus z squared, isn't it? Yeah. So then we're going to look at our constraint, g of x, y, z, which is that guy. And then we're going to take the partials, right? Del f. I mean, the partial is in the form of the gradient. So del f is what? 2x I plus 2yj plus 2zk. Does that make sense? And then del g, what would del g be? No product rule necessary. So we're going to take the derivative with respect to x. So we think of z as a constant. So that just means minus z would be your partial with respect to x. So that's your I component. And then your partial with respect to y would just be 2y, wouldn't it? So that's your j component. And then your partial, actually it's minus. Your partial, so we're taking the derivative of partials of this guy. Partial with respect to z would be just minus x, right? Does that look all okay to you? And then if we multiply through by lambda, it'll look like this. You guys buy that? Okay, so set corresponding components equal, that guy, or those guys, and then these guys, and then these guys. So then let's write down the equations. So 2x is equal to negative lambda z. 2y is equal to 2 lambda y. And then 2z is equal to negative lambda x. Is all that good? And then the constraint is just the surface. Y squared is equal to x times z plus 2. So we have this system of equations. So 2y minus 2 lambda y equals 0. So this is from the second equation. And then we'll factor out the 2y, which leaves us with what? 1 minus lambda? It's a pretty common thing to get, isn't it? So then you get two possibilities, either y equals 0 or lambda equals 1. So what if y equals 0?
Y equals 0.
Which equation can we use that to help us with? How about the last one? So yeah, we get, okay, we plug y equals 0 and we get 0 equals x times z plus 2, or x times z is equal to negative 2. Or z equals negative 2 over x. So let's take the first and the third equation. I don't know. I could say, I don't know if this is going to work. If not, I'll have to try something else. But I could say 2x over z is equal to negative lambda, right? And then I could do the same thing in the third equation and say that 2z divided by x is equal to negative lambda. So these left-hand sides are equal to each other, aren't they? So 2x over z equals 2z over x. That should tell us something. 2x over z, under this assumption that y equals 0, is equal to 2z over x. So we've got basically this system of equations here. So all this is saying right here is the same thing. Well, I'm sorry. This guy right here is saying 2x. I think that's what you're telling me, right? 2x squared is equal to 2z squared? Yeah? Or x squared equals z squared? Yeah, okay. So, well, what does that mean then? Well, I suppose if you take the square root, that means x is equal to plus or minus z, right? Okay. So that means that we could say that if x is equal to plus z, then we get z squared equals negative 2, right? Is that gonna work? Is z squared going to equal negative 2? No. So we could throw that one out. So if x equals plus z from this equation, we can say z squared or x squared equals negative 2. That's a contradiction. We're not going to allow imaginary numbers here. What if x is equal to negative z? So that would be negative z squared. The opposite of z squared is equal to 2. Negative 2. Yeah, and then that would mean z squared equals 2, or z equals the plus or minus root 2. Okay. And, okay, so what would that mean that x is equal to? Okay, x would be minus plus root 2, right? Because they're opposites in this assumption. Okay, so what critical values do we have? We have y equals 0. And then I think we can put it all in one because you can't mix and match the pluses and minuses here. So we could say x is minus plus root 2, and z is plus or minus root 2, or we could switch that around if you'd rather have plus or minus on the x value. It doesn't really matter. All right, woo! That made me think a little bit. And then I think the other possibility will hopefully be easier. Or lambda equals 1 is the other possibility, right? So if lambda equals 1, by the way, I haven't checked, but this might not. Well, all we have to do is plug that into f when we're done, and I don't think that'll turn out to be anything. No, I remember the answer, and that's not it. So that it's not going to lead us anywhere, I don't think. It can be a critical point and not be an extreme value. So lambda equals 1, where does that get us? Well, so we're not assuming that y is 0 in this case, right? So if lambda equals 1, what is the original set of equations up here? Well, in the box, what happens to this set of equations if lambda equals 1? So we get 2x is equal, whoops, I erased that on accident. We get 2x equals negative z. Is that right? So we get I'll try and fit it in right here. So if lambda equals 1, we get 2x is equal to negative z. What else? We get 2y is equal to negative 2y. No, that's wrong. We get 2y is equal to 2y. Okay, that doesn't tell us anything, does it? So we won't even write that down. We get 2z is equal to negative x. And then we still have the third equation. Y squared is equal to x times z plus 2. So I don't think this will be too hard to work with. All right. The first two equations, what could I do? I know that I could just, well, depending on how you want to do it, I could say, I don't want to divide. So I'm going to say x is equal to negative 2z. Does that make sense? And then plug in up here. Yeah. Okay. So that means we get what? Negative 4 times z is equal to negative z. That just means z equals 0, right? I add the z, that's what? Negative 3z equals 0. So either way you look at it, z equals 0. But what does that mean x has to be? 0. So we could plug into this one. Yeah, so y will equal plus or minus root 2. So we get 0 plus or minus root 2. 0 as our critical points. And then the idea would be to plug into, well, f, right? Because we're trying to minimize. So we'll get the same, for these guys, we'll get the same thing either way, right? Oh, so wait a minute. So we get 2. We only get 2 if we plug in here? Mm-hmm. Okay. So f equals 2. But I thought that, let's see. Using this one, we get 2 plus 2 or 4. F equals 4. So that's the max. But no, there is no max. We're trying to find the min. So this is nothing because it's not. Look, the thing about Lagrange multipliers is it doesn't guarantee the existence of extreme values. So you will get some critical value points that don't correspond to anything. Really, we're looking for the minimum, so we take the one that generates the minimum. Really, we're looking for the point values, though. So it's really, the answer is really plus or minus root 2 for y and then 0 for the other two coordinates. So those values of x and y and those 2 points will generate the minimum distance. If they generate the minimum square distance, they generate the minimum distance. And then this is just garbage right here. Because think about it. A surface like this, whatever it is, you can keep increasing x and z, and y will keep increasing. It can get as far away from the origin as you want. So it's not going to have a maximum distance.